So hi there, my name is Duncan Weatherson, and I'm going to be talking about Smile CDR. So Smile CDR is a FHIR data store for shared health records. I'm going to start out with a couple of use cases. In the past, I've made assumptions everybody kind of understands what a shared health record and a CDR is, but it's probably better if I just walk through some of them. So the first one is the main one. We're going to be talking about the use of longitudinal health records for jurisdictional organizations. So for example, if you were a state or a small country, province, creating a centralized health repository where you can store information. Our product is kind of the back end for that. Another area which we've got some interest in, where we think we can provide some value, is for the collection of data from devices, so medical devices. One of the imagined use cases we have is if you have medical devices across a number of countries or a number of jurisdictions where you've got different legislation, it'd be really useful to have kind of like a Akamai endpoint where you could send data to that was aware of the legislative obligations of the environment you're in. And so because of the way we've set our stuff up, you could put our application down in each of your jurisdictions and be well compliant, and then have a mechanism to gather that data back to a central view, which you could use for analytics or whatever your purposes are. Another core use case that we have is as a terminology server. So you can throw data in, terminology in, and then query obviously against it. And I'll talk a bit more about FHIR queries using the terminology server later on, but we can stand alone as a terminology server as well. Another use case of interest, specifically from some of our clients actually, is the idea of a cache, right? So because the data we have is dated, you can store data in the CDR in a way that you can retrieve it by time later on. So basically you can do an insert into the database, and then if you're interested in just the last 30 seconds or 2 minutes of data, you can do a query which gets that back for you. But then supposingly, if your system were, the source system were to fail, you could then extend the date on the cache and query data that's already sort of historically stored. So you get this mechanism in place where you can sort of be a cache in the traditional sense and then act as kind of like a failover or fail back for the case where one of your source systems goes out of isn't working right now. Another model that we have is the notion of an archival storage for sort of transition either off of a legacy system or just as a standard backup. So because the FHIR repository we have is essentially a standalone data store, it encompasses identity and encompasses the clinical stuff and encompasses all the other aspects of your data. The use that you could have out of this would be to take all of the information you have, say you were moving off of an old system, throw it as a bundle into one repository, and then keep it there. And if you ever needed to get it, because within the data store itself is all the information you need, you can query the information future date and try and get data back out, or you can retrieve all of it. So we think that there's, and there's some products out there which are already doing this, but we think that the data store we have is actually useful in that space as well. And then the last case is kind of the obvious one, is rapid application development for lightweight applications. So if you were a software developer who needed to implement a health solution, and you didn't want to be holding yourself accountable to all of the work associated with building a database and building the FHIR queries and all of the relational issues associated with that, you can spin up one of our servers very rapidly and start working almost immediately. So my partner and I have a lot of experience in working in the shared health record space. And previously we'd had some fairly challenging issues with some of the existing products. And so about 4 years ago, we decided that we'd start making a replacement for it. When we looked at the approach, we initially sort of talked about doing just a straight abstract data model. And then we looked at FHIR, and we found that, in fact, the FHIR data model was exactly the path we wanted to go. And so we kind of abandoned the idea of making a generic abstracted data model and mapping FHIR to it, mapping V to it, mapping everything else to it. In fact, we decided to go with just the FHIR data model and use that as our basis for the product that we're creating. So that's kind of like a bit of the background and the use cases that we have in mind. So with that, I'm going to sort of start talking about the solution itself. So our product is based on Happy. My partner, James Agnew, is the maintainer for Happy, and we have a few other sort of business partners with us on this, but at the root is the Happy libraries. What we've done is we built a wrapper around the Happy library, so it's a standalone application. You can put it down either in the cloud or on your prem and sort of start going right away with a FHIR solution. Part of the consequence of that is we've got a lot of history understanding how to maintain multiple versions at the same time. So one of the challenges people keep bringing up is the notion that FHIR is kind of a new standard. It's going to change. You don't have a lot of you don't have a lot of consistency between version 1 and version N, and how are we going to support that? Because we've been doing that in the past and happy anyway, we're pretty comfortable we can continue down that path. Because we use an abstract data model and not a data lake, we feel like it's relatively straightforward to map between the data objects as we go forward. And so we're comfortable with the notion that we're going to continue to support all published versions of FHIR in parallel. And like I said, that includes long-term version support. So we have a hybrid database design. On one side, we have a relational storage model, which is built to support pretty much any of the commercial packages that exist, so Oracle or Microsoft SQL. But on top of that, we also support Postgres, MySQL, MariaDB, and a few others along those lines. The intention being that we're not going to bind you to a particular data storage model underneath it. Whatever your organization's requirement is, you're able to sort of adapt to that. And then in parallel with that, what we have is we have a full text indexing system built on Lucene, which is kind of the same as Elasticsearch. This is actually really powerful because what it lets you do is build queries where you're using the standard FHIR query structure and then merge into that the full text indexing. So that you could do a query, for, let's say, all of the drugs that a person was on, and then pick some subset of a string that you wanted to look at to reduce that. Or another case where it'd be useful would be if you were looking up a patient, for example. If you wanted to do a query for a patient, you can use full text indexing to get the patient's name more trivially. And we also provide, as part of our solution, the ability to do type ahead. So if you give us a subset, we'll give you back a set of recommendations. So as the patient, from your UI perspective, as your user is typing, we can be feeding you hints back based on the full text indexing so that you can get your queries sort of more user-friendly. One of the other pieces that we're putting together is the ability to extend the indexing yourself. So if you're using FHIR extensions, we'll give you the capability in the relational storage space to add indexes associated with those extensions so that you can extend your query language very easily and gain some very rich stuff associated with that as well. Oops. So integrated terminology services. This is also another particularly useful thing, we think. What this lets you do is it lets you pick, for example, as part of your query, a subset of SNOMED. So for example, if you were querying for all of the labs a person had, and then you wanted to narrow that query down to a particular subset, you can use the integrated terminology services to say, get me all of the things that are within this subset of a particular terminology, and sort of make it more constrained for your users. The terminology services also obviously are able to handle just straightforward putting in of the standard in the standard format, throw in SNOMED or LOINC or ICD-10 and then just look up those terms as you would traditionally. So it's kind of an integrated service that lets you do both. I mean, obviously we're not competing with Apollon, but depending on what you want to do. So because we're a standalone application, we come with a web console. Part of the challenge when you're a library is that it's very easy to integrate, but you don't often have the tooling you need to be able to make the deployment simple and to make the configuration straightforward. So we've built in a web console. I'm going to talk in the following slides about some of the features in that web console. So the web console is pretty straightforward. I don't really have much else to say about that. So one of the aspects in the web console, in our console, is a full Swagger API interface, so you can test out using Swagger, build your queries. I'm going to talk about the features here. So our web console gives you all the tooling you need to be able to manage your solution. So you can see things like, I'll talk to them in a second, but you can see things like your performance. You can look at your user management. You can look at the logs. And so through this particular JSON API, we give you the ability to do tooling for that. So if you don't want to just use our API, if you want to integrate it into your own solution, you can use the tooling that we have in place and call the same sorts of features we have in our console for your service. So from a security perspective, we thought long and hard about security, and our solution, I mean, given that everybody else says the same thing, we're in healthcare, we all know the importance of this. Given that the space we're in requires the sort of granularity you need to be able to manage who's got access to what data, we built in our own roles and our own role mapping solution, as well as our own identity solution. However, we are willing to work with external solutions as well. So if you had some SSO, if you're using a Federation, we could participate in that. We've got the capability for working with SAML and OpenID. the granularity that we've built in goes all the way down to like the compartment level or the patient level, so you could quite easily create a rule allowing a particular participant to, or a particular role to engage with a subset of users or a subset of capabilities. We've sort of structured the security in such a way that we've got a lot of flexibility in terms of specific permissions and then general permissions and then role mappings for those. Critical, of course, to security is the ability to audit the activities of your users. Our solution provides a full audit capability. We track all of the activities done both at administrative level and all the queries that are done on the clinical side, so that if you have to go back and review what information has been accessed by your participants, or if you've got a privacy request, you have a full audit log of all of the events that you can interact with. Additionally, this is also available if you wanted to export it to your existing SIEM, for example, or if you had some other privacy solution which was supporting your application, we have a full integration capability down that path as well. So like I said, we have a built-in user manager. This allows you to create your own users if you wanted to. I mean, in general, our anticipation is as a participant in a regional system or as a participant in a broader integration, we'd expect that you're likely to have your own SSO and integrate. But if you had to do standalone, for example, if you were a small application developer or if you were using a targeted audience, we have the capabilities built in, and they're relatively robust. You can create super users, and you can apply them all to the role mapping system we already have. So I'm going to stop for a second here and talk about our integration from a Federation perspective. We spent a lot of time making sure that we were able to support the Smart on FHIR spec, and so standing up out of the gate, you can connect to our solution with your Smart on FHIR application and reasonably expect it to work. At this point, I often do the Boston Med demo with the growth chart. Because we have a constrained time, I'm just going to keep talking for now. But the solution out of the box is fully compliant. Open auth endpoint, and you can use your existing Smart on FHIR applications to connect and get data directly out for yourselves. Additionally, so in the environments that we've worked in, we found that, so if you were dealing, for example, with a regional hospital system, one of the challenges that you have is you have to be able to allow the clinicians who are working on these legacy HISs to be able to relatively trivially continue to use their current system and then easily gain access to external systems. With that in mind, we sort of support the federated model in general. So the idea being that, and we've seen this with Meditech and a few others in the past that we've worked with, where you can provide a link to an external system from within the HIS, make a reference out of that, and as long as you're able to pass some federated information either through security token service or through the native built-in capabilities of the solution, you can then land on an external system in context. So you pass out the patient identifier that you have, you pass out the reference, and you land in a system that's actually giving you data. So we fully support that kind of model. So here's monitoring. This is actually an important point because when you're building a solution to be operated, you need to know that it's functioning, right? Especially in the clinical space. And often when you get the packages, so for example, Happy, out of the gate, we've got a library. There's no good way built into the solution to tell you what the status of your application is. You're dependent on external tooling. You're dependent on the system capabilities that you're using. So in our solution, we actually took the time to make sure that we have a set of full system monitors showing you the availability, showing you the performance, whether you got latency, and that's all packaged as part of the UI. All right. Wow, that's amazing. My timing was exact. So here's a key element that I think is really important. FHIR supports the notion of profiles, and we spent a lot of time figuring out how we're going to deal with that. The capability you have is to set profiles in our solution, and then based on your needs, you can do profiling validation either on the way in, on the way out. And we give you the flexibility to be able to mark stuff as either suspect or flat out reject it. So for example, if you're receiving data from an existing data store and you want to apply a profile to it and it doesn't match the profile, you've got the opportunity to say, I'm going to save that data anyway because you don't want to lose data, or you could say reject it, send it back for subsequent evaluation. And then once again, on the way out, you could do the same thing. You could either choose not to display data that had been previously marked as suspect because of data quality issues, but you reserve it for later fixing, or you could send it to your consuming system in a way that lets them know that there was some validation issue with the data that you received. But it gives you lots of flexibility not to throw away data, and it gives you the ability to sort of maintain control over the data quality at the same time. And we experienced this in some of our other systems. We've had systems which were for regional integration where, because of the strictness of the profiling, they threw away 20 to 30% of the data, whatever some hospital wasn't able to meet the need. And it caused an ongoing problem. So this is really based on some integration experience we've had in the past. So flexible data integration options. We currently support ORUs and ADT from HL7v2, and we're looking at others, but we try to get the big ones first. We're working with some partners to also support CDA integration because there's a strong existing data set that fits in that space. And we're looking at ways of doing integration with real-time systems so that rather than being an after-the-fact aggregator, you can, as transactions happen, hook into existing data sets and pull them in. Our solution is designed to be flexible in that way, so we've got a lot of integration capability. We're slowly working through the list of popular models. So we're designed to be almost infinitely laterally scalable, right? So as long as your backend database is able to be structured in such a way to keep up with the load, we don't maintain a lot of context within the specific node. So you don't have to, we're almost, sorry, losing word here. You can go through any individual node and then come back from your load balance perspective on a second node and on a third node, on a fourth node. We're not tying you back to any one system. There is, we're stateless, there we go, sorry. We're basically stateless in each of our systems so that when you come through, you get a connection, and if you come back, you can basically use a load balancer in a round-robin state to sort of spin across all of the instances. So our deployment models, I just want to talk about this briefly. I've got 2 minutes remaining. We're able to be deployed in the cloud, and we will fully manage it in the cloud for you. We can also do a local deployment fully managed. So because we're a standalone application, we can put it into your data center. You can have it on your own prem, and you can use it in the ways that suit you. If you want full support, we'll give you full support. If you'd rather manage it locally, that's also available to you. Like I said before, we're able to work with a number of different databases: Oracle, MariaDB, Postgres, MySQL, Derby, Microsoft SQL, and others. We're in a cluster configuration for high availability, and we support geodiversity across data centers and across regions. That's kind of the end of my presentation. Thank you very much for listening.